Hello students. In this playlist, we are going to discuss PYQs of JEE Mains. First, let us start with shift 1 on April 2nd. So, in this first question, here they are saying let alpha and alpha plus 2 be the roots of the given quadratic equation, where every term is in the form of a minus b into a plus b. So, this can be written as a square minus b square. So the first term becomes x plus 1 whole square minus 1 and x plus 2 whole square minus 1 and so on x plus n whole square minus 1 and that is equal to 4. So this can be written as summation x plus I whole square minus n equal to 4n and summation of x plus I whole square is x square plus I square plus 2xi. This is equal to 5n and summation x square plus 2x summation of I plus summation I square equal to 5. Summation x square is nx square plus 2x summation of I is n of n plus 1 by 2 and summation I square is n of n plus 1 into 2n plus 1 by 6 equal to 5. Here you can cancel this 2 and 2. If you take n common on LHS, you can cancel it with n on RHS. So you're left with x square plus n plus 1 into x plus n plus 1. N plus 1 into 2n plus 1 can be written as 2n square plus 3n plus 1 by 6 minus 5. And we know that roots are alpha and alpha plus 2. So sum of roots alpha plus 2 is equals to minus b by a. So 2 alpha plus 2 is equals to minus of n plus 1. Alpha equal to minus of n minus n plus 3 by 2. And coming to product of roots, alpha of alpha plus 2 is equals to c by a. And alpha is minus of n plus 3 by 2. Alpha plus 2 is, if you add plus 2, you will get 1 minus n by 2 equal to c. The value of c is, this becomes minus 30, so minus 29. 2n square plus 3n minus 29 by 6. You can cancel 2 here and 2 3's. Due to the cross multiplication, you will get n square plus 2n n square plus 2n minus 3 into 3 equal to 2 of 2 n square plus 3n minus 29. So this becomes 4n square minus 3n square is n square. 6n minus 6n becomes 0. Minus 58, if you send it to other side, you will get minus 58 minus plus 58 minus 9, which is equal to 49. So n is equals to plus or minus 7. Since n belongs to natural numbers, n equal to 7. If you substitute n equal to 7 here, you will get alpha equal to 7 plus the 10 by 2, 5 minus 5. So n plus alpha is equals to 2. So the first answer is, let us move on to the next question. So the second question is saying, let x and y be real numbers such that it satisfies this equation. Okay, so we have to find 10 of x minus 3. So let us rationalize these two fractions. So we'll get 50 of 2x of 1 minus 3i by 1 plus 9 minus y of 1 plus 2i by 1 plus 4 equals to 31 plus 17 So this becomes 10. So we multiply it with this, we'll get 10x. So 10 5s, 5 2's 10, 10x minus 38 minus, here we'll get 5, 5 10, so 10y minus 20y equal to 31 plus 17i. So you're left with 10 of x plus x minus 1 minus 10 of 3 plus 2y equal to 31 plus 17. From this you'll get two equations. One is 10 of x minus y is equals to 31 and minus 10 of 3 plus 2y equal to 7. X minus y is equals to 3.1 and 3 plus 2y is equals to minus 1.7. We should be getting 30x here. So this is 3x. So it becomes 3x. Okay. If you multiply this with 2, you will get 2x minus 2y is equals to 6.2. Now, that was in this equation 1 and 2. Equation 1 plus 2 will give you 5x is equals to 6.2 minus 1.7, which is equal to 4.5. So x is equals to 0.9. If you substitute this in this equation, you will get y is equals to 0.9 minus 3.1, which is equal to minus 2.2. So we are told to find 10 of x minus 3y. So 10 of x plus 3y. So 10 of x minus 3y, not x plus 3y, x minus 3y. That is equal to 10 of 0.9 minus of minus plus 6.6, which is equal to 10 of 7.5, which is equal to 70. So for second question, the answer is option B. Let's move on to next question. Okay, here he's saying let alpha and beta be such that the system of linear equations has no solution. First, let us write the augmented matrix, which is 1, 2, 1, and 5. Then 2, 1, alpha, and 5. Then 8, 4, beta, and 80. So let us convert this to echelon form, for which let us make this as 0 first. So the first row remains same, 1, 2, 1, 5. And coming to second row, let us convert R2 to R2 minus 2R1. So you'll get 0 here. And 1 minus 4 is minus 3. And then alpha minus 2. 5 minus 10 is minus 5. Then 8 minus 8. So let's convert R3 to R3 minus 8R1. So you get 0. Then 4 minus 16, which is minus 14 minus 12, beta minus 8, and then 18 minus 14, which is equal to minus 22. Now let us make this as 0. So let us convert R3 to R3 minus 4R. First row remains same. So 1, 2, 1, and 5. Second row also remains same, minus 3, alpha minus 2, then minus 5. But the third row changes. So you'll get 0 here, and minus 12 plus 12 becomes 0. Beta minus 8 minus of 4 alpha minus 8 equals to beta minus 4 alpha. And this becomes minus 22 plus 20. So minus. Since the given equations has no solution, this term should become 0. So beta minus 4 alpha equal to 0, which means that is what we have to find. We have to find the value of beta by alpha. So beta is equal to 4 alpha. Beta by alpha is equals to 4. So the answer is option B. Let us move on to next question. So let A is equals to a 2 cross 2 matrix. B is also a matrix. There are two equations. Then among the two statements, okay, this is a statement type question. So first let us look at this first equation. A square minus 4a, transpose the I to the other side, you will get minus I. If you take a common, a of a minus 4 is equals to minus I. A is nothing but 1, 2, 1 alpha. We subtract with 4i, we will get 1 minus 4 is minus 3, then 2, 1, and alpha minus 4. That should be equal to minus 1, 0, 0, minus 1. So minus 3 plus 2. Minus 3 plus 2 is minus 1. Then 2 plus 2 alpha minus 8. Minus 3 plus alpha. And then 2 plus alpha square minus 4 alpha is equal to minus 1, 0, 0. So from this, clearly alpha equal to 3. Let us look at the second equation where b square minus 5b is equals to 6i. So b of b minus 5i equal to 6i. What is b? B is 3, 3, beta, and b minus 5i is 3 minus 5 minus 2. 3 minus, okay, we'll get that. Beta minus 0 is beta. 2 minus 5 is minus 3. And this is equal to 6, 0, 0, 6. So 3 into minus 2 is minus 6 plus 3 beta. Then 9 minus 9 is 0. Minus 2 beta plus 2 beta is also equal to 0. 3 beta minus 6. So clearly 3 beta minus 6 is equals to 6. 3 beta minus 6 equal to 6. That means beta equal to 12 by 3, which is equal to. So alpha equal to 3 and beta equal to 4. Let us look at the first statement, which is b minus a into b plus a whole transpose. B minus a into b plus a whole transpose equal to 13, 15, 7 and 10. 13, 15, 7 and 10. So this is our statement 1. Let us solve the LHS. So what is B actually? B is 3, 3 beta 2. 3, 3 beta is 4, 2 minus, and what about A? A is 1, 2, 1 alpha. 1, 2, 1, 3 into same thing 3, 3, 4, 2 plus 1, 2, 1. So this becomes 2, 1, 2, not 2, 3, then minus 1 into 4, 5, 5, 5. That is equal to 8 plus 5, 13, 10 plus 5, 15, 12 minus 5, 7, 15 minus 5, 10, which is equal to, which is not actually equal to, because we have to transpose this whole thing. So if we transpose the whole thing, we'll actually get 13, 7, 15, and 10. That is not equal to the RHS here. So statement 1 is false. Let us look at statement 2, which is beta of adjoint of a plus b equal to minus 5. So beta of adjoint of a plus b is equals to minus 5. So beta of adjoint of what is a plus b? We already found a plus b, which is equal to 4 triple 5s. 4, 5, 5, 5. So adjoint of this becomes 5 and this becomes 4. These two becomes minus 5 and minus 5. This is the adjoint of matrix, and determinant of this matrix is equal to 20 minus 25, which is equal to minus 5, which is equal to RHS. So statement 1 is false, statement 2 is true. So that is statement 2 is only correct. Let us move on to next question, fifth question. So what is fifth question? Let A be a set of first 101 terms of AP, which first term is 1 and common difference is 5. And let B be a set of first 71 terms of AP. Okay, so there are two sets. Set A contains 1 and then common difference is 5. So you'll get 6, 11 and so on up to how many terms? 101 terms. And B starts from 9. The common difference is 7. So you'll get 16 and so on up to 71 terms. The number of elements in A intersection B which are divisible by 3. So let us write the common standard form of this first AP. An is equals to A plus n minus 1 into D. So there are two APs, so let us write this as n minus 1 into D. D is 5. So we'll get 5n1 minus 4. This is An. And let us assume this as Bn, which is equal to 9 plus n2 minus 1 into 7. So you'll get 7 into plus this is Bn. For A intersection B, these two should be equal. So you'll get 5n1 minus 4 is equals to 7n2 plus 5n1 is equals to 7n2 plus 6. So if we convert this to 5n2 plus 5 plus 2n2 plus 1, clearly LHS is a multiple of 5 and this is also a multiple of 5. So this should be multiple of 5. So let us check the possibilities for 2n1 plus 1, 2n2 plus 1 to become a 5 multiple. So n2 should be equal to 5m minus 1 by 2. The numerator should be divisible by 2, so m should be a odd number. And let us look at the values of n2. n2 can be equal to, if m is equals to 1, you will get 2. If m is equals to 2, you will get not 2, 3. 15 minus 1, 14 by 2, 7. Clearly, this becomes a AP where the common difference is 5. So you will get 12 next and so on. And what is the one more condition? The one more condition is n2 should be less than 71. And n2 is also AP, which is in the form of, let us write this as L, last term, is in the form of 2 plus a minus 1 into 5. That is equal to 5a minus 3. This 5a minus 3 should be less than 70, less than or equal to 71. So 5a minus 3 should be less than or equal to 71. A should be less than or equal to 74 by 5, which is similar to 5 ones 5 fours 20, 14 point something. So A can take 14 values. If A takes 14 values, N2 also takes 14 values. So N2 is equals to 2, 7, 12. We are adding 5 to each term. So we'll get 17, 22, 27, 32, 37, 3, 3, 6, 8. Okay. So 42, 47, 10, 52, 57, 1, 2, 3, 4, 5, 10, 2 more. So 62 and 67. These are the possible values of N2. So we know that there are 14 elements in A intersection B, but they should be divisible by 3. So what is the A intersection B? We can write it as set where all the elements are in the form of 7 and 2 plus 2. 7 and 2 plus 2. But now N2 should belong to, let us give this a name as C, so it should belong to C. This should be divisible by 3. This is already in the format of 6n2 plus n2 plus 2. This is a multiple of 3. This should be a multiple of 3. So let us check the possible values of n2. 2 plus 2 is not divisible by 3. 7 plus 2 is divisible by 3. So 24, 27 plus 2 is not divisible by 3. So 39 is divisible, 42 is 44, 49, 54 is divisible by 57 is not divisible. Okay. So you will get 1, 2, 3, 4, 5. You will get 5 elements in A intersection B which are divisible by 3. So option is B. So we'll discuss next 5 problems in the next part.